Hi, I am Anubhav and I want to show you an intelligent chatbot that I built for Lakeshore Technical College. This application answers student questions about admissions, financial aid, and campus life in real time. Let me demonstrate how it works. Lakeshore Technical College receives hundreds of student inquiries every week. Common questions like how much does tuition cost or what's the application deadline are asked repeatedly. Staff members spend hours answering the same questions over and over. I built this chatbot to solve that problem. Instead of waiting for a response, students can get instant answers 24/7. Let me show you how it works. Let's start with a financial question. I will type how much does tuition cost? The chatbot instantly recognizes this question and provides the answer. Notice the answer is specific and immediately useful. It also provides a link if the student wants more details about payment options or financial aid. They can navigate to the relevant page. All of this happens instantly, no waiting for staff response. Let's try an admission question. How do I apply for financial aid? Again, the system instantly recognizes the question and provides guidance. This is helpful because the student knows exactly uh, what to do and what not to do. They don't have to make phone calls or send emails just to get basic information. Let's try another category. I will ask about on-campus housing. See, even though it's a no answer, it's helpful because it directs the student to resources. The links in the chatbot guides them to the right office for further assistance. One important feature is that the chatbot handles different ways of asking the same question. Watch what happens when I ask about tuition in a different way. The chatbot understands variation in how people ask questions. This is important because real users won't ask questions in exactly the same way every time. Now, we will see what happens if someone asks a question to the chatbot that it does not have an answer for. Let me ask something outside of our knowledge base. See, it gave something different. I think it's a little bit malfunctioning. That's something that I will fix later. Notice the chatbot doesn't crash or give a confusing answer. And also let me show you another example. I will ask about scholarships. Chatbot provides helpful information and it directs us to the right resources. Each answer is organized in a readable format with relevant information and links. The conversation history is visible, so if a student asks multiple questions, they can see the flow of the conversation. Now let me explain the technical side of this application from a computer science perspective. This chatbot works on several key principles. First is data structures. I have organized multiple frequently asked questions in a structured data format. Each question is mapped to its answer category and a relevant resource link. This allows the system to efficiently find and retrieve information. Second is the search algorithm. When a user types a question, the system compares their input against the stored questions. It finds the best matching question and returns the corresponding answer. This is a straightforward matching algorithm that's fast and reliable for this scale. Third is the user interface. The interface is built with clean design principles. User messages and bot responses are clearly separated. Answers are formatted for readability, links are provided for additional resources, the conversation history persists so the user can see the flow. Fourth is the client-side processing. All the computation happens in the user's browser. The data loads once and then searching happens instantly without needing to contact a server. This makes the experience fast and responsive. And fifth is scalability. The architecture is designed for growth. If Lakeshore needs to add 100 more FAQs, the system still works efficiently. The structure is organized by categories, making it easy to expand. These are core computer science concepts: data structure, algorithms, user interface design, and system architecture. And the real impact demonstration of this is that currently staff at Lakeshore spends significant time answering repetitive questions, and this application changes that workflow. Instead of students waiting for an email response to how much is tuition, they will get an instant answer. Instead of staff fielding the same questions 10 times a day, they can focus on more complex student needs. The application also demonstrates that I can build a practical software that solves real problems. It's not theoretical, it's functional and useful today. This project showed me that I love building applications that help people. It made me realize I want to deepen my skill and build more sophisticated solutions at university level. Well, building this application taught me many important lessons. Simplicity works. I did not build a complex algorithm. A straightforward matching approach works well and is maintainable. This is good engineering. User-focused design. The best applications solve real problems for real people. A student does not care about my algorithm. They care about getting their answer quickly, and testing matters. I tested different questions, phrasing, edge cases, and scenarios. This revealed issues and helped me build a robust system. And there's always more to learn. Now that I have built this foundation, I see many opportunities for improvement. I could add natural language processing to understand intent better. I could implement machine learning to improve matching, and I could add analytics to understand what students need. These improvements represent skills I am excited to develop at UW Madison. The computer science program will teach me advanced techniques in databases, machine learning, NLP, and system design. And this project was just the beginning. It proves I can build something real and it shows me where I need to grow. I'm excited to bring this problem-solving mindset and hands-on experience to UW Madison's computer science program. Thank you.